What does someone mean when they say displacement? It's the same as distance. What makes it different from distance? Today we'll be exploring this biomechanics concept. Everyone knows that distance is a measurement of how far an object has traveled. But what about displacement? First we will define distance and displacement. These are defined by scalar and vector quantities. Scalar quantities are described by numerical quantities, for example, how far you physically have walked during a hike. Vectors, however, are described by both a numerical quantity and a direction. For example, the change in position of a golf ball when it's hit. When hitting the ball, the distance may be 20 meters. However, the displacement is only 10 meters northwest. So the ball is only 10 meters in a straight line from its initial position, this being where you actually hit the ball. Distance is defined as a scalar quantity that refers to how much ground has been covered during an object or person's motion, and only has a magnitude. Displacement is a vector quantity that is defined to be the change in position of an object. Displacement has a direction as well as a magnitude. Here's an applied example of the differences where we can see a HD level biomechanics student walking around the room in random directions for no apparent reason. The distance is the measurement of the total amount of ground that has been covered. So if we measure from point A along the path of movement, he goes 10 meters north, 5 meters west, 5 meters south, and 5 meters southeast. We get a total distance of 25 meters. However, if we were to measure the displacement, we would measure the change in position of an object from its initial position. In this example, the biomechanics student has had a net change of 0 meters. He is now back at his starting position. At different points, we can refer to the displacements at different magnitudes and directions. So at point B, he has a displacement of 10 meters north, and at point D, he has a displacement of 5 meters northwest. In biomechanics, we may use distance versus displacement when analyzing an athlete's running or walking technique. This technique can be done in programs such as Canovia, shown here, where we use specific anatomical points to track the movement and angle of different parts of the leg. Canovia is a video player for sports analysis that provides a set of tools to capture, slow down, study, compare, and annotate technical performances. By using distance, we can determine the length of the change in knee position during a stride, which may give us useful information about the total distance the knee moves in each stride. By using displacement, however, we can determine the length and change in direction of the knee at different points compared to its initial starting point. Here we are showing the different angles and position of the knee relative to the ankle. We can also determine the reproducibility of a stride and the accuracy at which the knee position starts and finishes from stride to stride. This is important because you want some minor differences to prevent any overuse injuries. I hope this gives you a thorough understanding of distance versus displacement and how we use it within biomechanics. Thank you.